Okay. Yesterday we were discussing about the some partitions. So we were able to write the partitions, but we are not able to see the number of partitions the data set has been distributed into, right? So for that, I said that we need a paid account, the subscribed account. So I have spinned up the cluster for that. Okay, I have created a single node cluster. I'll show all this to you. So this is the Databricks. Sorry, first let's go to Azure portal. Okay. If you remember, we have created a Databricks account earlier in our Azure account, but we were not able to use the multi-cluster or more than one node cluster. We are not able to use it. So I have made some settings. I have made changes to the settings to spin up the more. That is a limitation on the cost and budget. So that's I have removed that limit and I have spinned up this. So now it is okay. In the real time, you no need to worry about all of that. It is already configured and the setup is already done. So let's open our Databricks account. This is the Databricks account we have created earlier. This is Azure Databricks service. Okay, last view. Okay, okay, let's launch this workspace. Okay, so this UI looks similar to the community edition. There is no difference at all. This is similar to the community edition, but the features, whenever you go through each of this compute catalog, you will observe the differences. Let's go to compute. So I have already shown in the community edition, you are not able to see this create option. Okay, but in the paid version, you will be able to see this. Okay, I have created this test cluster, that too with a single node, but let me create another one to show you. Okay, so provide any name to this cluster. Let's make it as the training cluster. Okay, choose the policy as unrestricted. Uh, Go with the default version. This is the runtime. This is like a package which will be combined together and provided to us to use with our notebooks. Okay, so that is the runtime. So preferred worker type. So you can choose the number of workers you need from here. So these are the various worker types. D4, D8, D16. It is like the power is more. D4 is the minimum one we have. It comes with 16 GB memory and 4 cores. D8 is like 32 GB memory with 8 cores. So as you go on, the size increases and accordingly the cost also. So let's choose the first one, which is 16 GB 4 cores. So here we should select, okay, this one. Okay, let's select this as 3. 3 is also not available. Let's make 1 and this as the 2. Let's try that. Uh, 1 second. I have spinned up this. Okay, let's refresh 1 second. So it is all limitation on the quotas. Okay, so let's go with this. Let's try to create. Okay, 32 GB. So this type of worker node is available. So don't worry about this right now. So just go with whatever is available here. So minimum nodes, you remember the Snowflake multi-cluster warehouse. There we can specify the minimum number of machines and the maximum number of machines. The same thing here also. Let's say the minimum is 2 and I want a maximum as 4. Okay, let's say terminate after. This is like auto resume and auto suspend. Enables auto scaling, which means the based on the workload, it will scale between the 2 and 4 and it will terminate after the here we have to provide the number of minutes. Let's say after 10 minutes of inactivity, I want to suspend this cluster. Okay, so let's try to create it. Okay, it will take some time for configuration. Okay, it is getting created. Okay, now getting created with the current timestamp. This will take a little time. So meanwhile, what I'll do is I'll go to this catalog option, open it in a new tab. Let us also open our community edition of the Databricks. This is the free trial. Community or the free trial is the same. I'll show you the differences between what is not available in the free trial editions and what is there in the paid account. So organizations, they'll definitely go for the paid accounts because they need all the features and security also. So this is the community edition. Here, if you see, let's go to catalog. And this is not logged in through community account. Okay, 1 second. What is this account? Okay, this one. So let's see what account is this. All of them are using the same email. Okay, this is a different email. Okay, let's open this in a new window, the Databricks free edition. Let me open it in a new window or new incognito window because it is using the other account details. Okay, Databricks. Let us get my account name. This is the one. I don't remember password for this. Let's see. The username you have entered is not associated with the account. 1 second. This is not the. Okay, what I'm trying to do is, generally in the community editions, you will not be able to see these options: govern, connect, and share, because these are Databricks Unity Catalog related features. Generally, Unity Catalog is not enabled in the free trial accounts or the community accounts. But I see some cross subscription happened. Okay, let it be. Let's try to see here credentials. I want to connect to the external location or a data lake. Okay, so let's try to connect here. First of all, in order to connect to the data lake, we need some credentials. Okay, that credentials will be available here. See here, we do not have any credentials right now. So if I go to the paid account, go to catalog, mm, go to catalog, okay, connect and credentials. So this one I have created it. Okay, the first one I have created it, and this second one, this is auto created. When you create a Databricks account inside the Azure, the connection will be auto created. Okay, so now let's try to create it here. So it will be difficult. We won't be able to do this. Here we either need a IAM role. This is AWS related. Okay, the credential name, the role ARN. We need some details. Let's try to see open our AWS account. I think it would make you confused. One we are using it on Azure, another one we are using on AWS. Okay, first let's complete this Azure one. We will switch to the free trial account later because this needs some additional settings. You will get confused. Okay, so now go to Catalog Explorer. This is the credential. We need some way of authentication to the data lake, right? That way of authentication is using this credentials. This is auto created whenever we are creating Databricks inside the Azure. That to a paid account, not a free account. Okay. So now let's try to create a credential. Assume that this is not existing. Okay. I'll tell you why we need another credential if we already have this. This is a this becomes the managed location. Yesterday we have discussed the external table and the managed table, right? So even though the credential is created, it is on the external stage. This is external. This is not really an external stage. This is a Unity catalog related location. Okay, this is a Unity catalog related location. So if you use this, then also it becomes the internal or the managed one. So that's why we need to explicitly create a external stage location in order to uh, place the tables in externally and in order to place the files externally. So imagine that this is not available and this is the default one. It has come. Let's create a credential. So this is to access the storage account. So the credential type is Azure Managed Identity. The credential name, you can provide anything. So let's name it as ADB test thread. Okay. Connector ID. So this you will get it from the Azure. Let's go to Azure Home. Here you need to search for, if you are spinning up the Databricks account in the Azure, you will get this option. Access, you have to type here, access connector for Azure Databricks. Access connector for Azure Databricks. Okay, oh, you will see this. I did not create it. It was there by default. Whenever you spin up a Databricks account, in the paid account, in the paid subscription, you will automatically get this. Okay, so open this. Here there is a resource ID. Okay, that you need to copy. Resource ID you need to copy and provide it in the access connector ID. This will be the access connector ID. Okay. So here I am not doing anything. It is like I am trying to create connection to the data lake. That connection to the data lake requires a authentication mechanism. Earlier in the ADF we have used a link service with the subscription method. Here we are using managed identity that requires a access connector ID. That access connector ID is this resource ID from the Unity catalog. Okay. Unity catalog is nothing but it's a combined database or a data lake where we can store tables, files, etc. Earlier also we are able to store the tables and files without the Unity catalog as well. So what additional things comes with the Unity catalog is uh, you will be able to take care of the data security, governance, metadata management, and centralized layer where you can maintain the data. Okay. So let's see first, try to understand the Unity catalog. This is the feature of Databricks, not the feature of PySpark. Remember that this is the feature of Databricks, not the feature of PySpark. We are learning Databricks in combination with the PySpark. Okay. So it is the unified governance layer for data and AI assets on the Databricks platform. It provides a single interface to manage access, security, and tracking for structured and unstructured data, machine learning notebooks across cloud environments. So, what are the key things here? Centralized access control. Before the Unity catalog, so if multiple people are working, not multiple people, if there are multiple projects using the Databricks, for each of them, they need to maintain a different workspace, meaning that different folder, and at a folder level, we need to maintain the access. Okay, at the folder level, you need to maintain the access. But with the introduction of the Unity catalog, you no need to manage the workspaces. In the single workspace itself, you can manage multiple projects. But earlier to the Unity catalog, for each project, we need a separate workspace, separate access to that. Everything is a separated. But with the Unity catalog, this management has become easier. Okay. So manage permissions for tables, views, files, and volumes and models using standard SQL queries. So you remember in Snowflake, we have created some roles and granted the roles to the users, right? So the same way of thing we can do it here, but all of that we are not going to discuss. That becomes a huge DevOps thing. Okay. So the data lineage, it automatically tracks how the data is sourced, how the data is built from source to the destination. And auditing maintains the transaction logs. Okay. Uh, Discovery. offers searchable interface with tagging and documentation features to help users find and understand available data. So this is like a kind of documentation or the metadata about the data, which will help us to find something if we are searching. Okay, it also enables security and AI governance. So Unity Catalog comes with many features. So one is the centralized access control, data lineage, auditing, data security, all of that. Okay. Secure data sharing. Data sharing is nothing but the same concept. The snowflake, if somebody is not part of our account but still they have their own account and want to see our data, we create a data share and provide them the read access. The same kind of thing is applicable in the Unity catalog as well. Okay, what Databricks is trying to do is it is trying to bring all the features together, which will be like a single tool which supports all the things. AI, data engineering, Power BI, or the analytics people, everybody can rely on this single platform. That is what they are trying to do. They are trying to attract users so that they can heavily rely on this Databricks without going to another tool. So this is a strategy to improve their business. Okay, so if we have everything in the one place, why we need any other thing, right? So managing one resource is easier than managing multiple technologies. That's why. So this is still in the creation mode, let it be. So now, meanwhile, let's create this. Okay, Azure, we are creating a credential to connect with the data lake. Okay, advanced options. So leave about this. If we limit this to only read only use, so we will be able to only read, we will not be able to write the data. So don't worry about this, leave about it. So just go with the creating credentials, create. So credential type is managed identity. This is for the purpose of accessing the storage. Read access is disabled. It means we will be able to access fully, not only read. This is the connector ID. Okay, right. So now usage, permissions, workspaces. These are all not our things. That is taken care by again the DevOps. But at least this creation is also not our thing. But in order to use that, we need it. We don't have any other person to create it, right? So that's why we are doing it ourselves. So now we have the credentials. We have the keys to access the data lake. Now you need to connect the connection to the data lake. So before to that, we can create a new folder in the location we are going to use. This is our data lake. Okay, so in this, go to containers. Let's create another container, external Databricks Unity catalog. Okay, external Databricks Unity catalog. So let's create this. Inside this, maybe I can have another folder. Let's just make it as Databricks Unity catalog. Okay, external location. Unity catalog external location. Okay, directory is created. Now let's go to this explorer. Now create the external location. Okay. So leave about all of this. Initially, this was the only one. Okay, this is the only connection we will be having without us creating it. Okay, these other two I have created it. Ignore about that. Okay, this is the credential. Sorry, this is the external location. If you see here, there is some location. This Unity catalog, the first part ABFSS. After that, there is a Unity catalog storage. That is the name of the container, and at the rate followed by data DB storage. Something is there, right? OALK. So that is the storage account name. So I can open that. That is auto created. It is not created by me. That is automatically created. That container and uh, storage account is automatically created. I am not the one who is has created that. So this becomes the managed storage. If we are creating the tables or files in the managed location, or if it's a managed table, the files will go into this. Okay, without the Unity catalog earlier, we are not able to see where our files were, right? Now, even with this, we know that it will go into this location, but we will not be able to access. Let's see. Go to external location. Sorry, the storage. This is the storage account name. Okay. Inside this, we have the container. What is the name of the container? Unity catalog storage. Containers. Unity catalog storage. But we will not be able to access this. See here, because this is managed by the Databricks. We don't have access to see this, but the files will be stored at this particular location. Okay, we don't have permissions to see this. This is how the Databricks or the Azure operates. They don't allow us to see the files here, the managed files. Because why we need to worry about the managed files? Because it is taken care by the Databricks itself. Why we need to interfere in that? So that's why they will not allow access to this. But we have created an external location. There we can uh, go to that location, access the files, see the tables or the files, everything we can do it over there. Okay, now let's create an external location. So the location name, you can provide any name here. The training external location. Okay, so what is the storage type? Azure Data Lake. S3 is related to AWS, right? So Azure Data Lake storage. Here we need to provide our details. This is the format. Okay, first let's try to write it here so that we will not miss this. If we start writing it, I'll not be able to see here. See, as soon as I type here, I'll not able to see that. So that's why for reference, I'm writing it here. ABFSS. This is the standard format you have to use. Okay, colon, double slash. Here it is asking for the container name. We should provide the container name we have created in our own storage account. This is our own storage account. Here, go to containers. This is the container I have created. We have created right now. Okay, external. One second. This is the container. External Databricks Unity catalog. This is the container name. At the rate, there should be at the rate. This less than greater than symbols indicates that's a placeholder. Not keep these symbols. So at the rate followed by the storage account name. This is the name of the storage account. Data lake. Sorry, DE training data lake. This is the name of the storage account. So that should be provided here. After that, what? After the storage account name dot dfs dot core dot windows dot net slash. Here it is asking for the path. Okay, if you see here, there is a path. So which path I should give within this container? This is the path. Okay, so what I'm doing, I'm creating a external location which the Databricks can access, the storage location which the Databricks can access, and we can keep our files or tables in that location. Okay, so I'm creating this as the path for this. Now let's see storage credential. So we have created the credentials, right? So we need some way to authenticate this. That way is nothing but the storage account. So I think this is the one we have created, ADB test credentials or ADB training credential. Okay, I think this is the one ADB training. Both of them work the same. ADB test or ADB training, I don't remember. So both of them has the same thing. Okay, so let's use this ADB training. And now go to advanced options. See here is also there is an option to limit only read. So I don't want to limit to only read options. And file event type. Let's go with the automatic one. If you select automatic, then the storage queue and the event subscription will automatically created. You can choose to provide your own storage queue. It means if we provide automatic, whatever files we are uploading into the storage, that will be auto detected in case you want to implement something like uh, auto loader. Auto loader means as soon as the file is available on the storage, that should be loaded to Databricks. That is auto loader. That is meant for streaming. Stream. Uh, this is a different concept. Streaming and batch processing. Batch processing means once in a day or once in an hour or based on the frequency, we will be loading the data. That is called batch processing. And when we say streaming, as soon as the data comes into the storage location, we need to trigger the pipelines to load the data into the tables. So that is streaming. Streaming is the real time, and what is the other one? Batch processing. There is some delay between the source and the destination. Okay, that is the thing. So now these are not mandatory, but you can choose to fill it from the connector, resource group, and the subscription ID, under which account you want to get charged for this. So autofill from the access connector. So there is a resource group created for the Databricks. It is auto created. It is not created by me. And subscription is also auto created. Let's create this. We are creating an external location. Let's create it. Okay. It is giving some error. Uh, I think we have used another credential. Let's go back. Let's try to use the other credential. ADB test. Let's try with this. Go to advanced options. Okay, it is autofill from access connector. Let's create. Okay, let it be, no problem. So let's force create it. It is giving some file events permission not verified. Let it be, no problem. Let's force create it. Okay, it is created. Now the location is this one. Read. It is not only read only. Uh, it has full access. I mean to say, file events enabled. Okay. So now mm, we are not bothered about the permissions because this permissions is taken care by um, DevOps thing. So we are not going into that part now. So, and one more thing, what we have to do is on this container, on this external container, I need to provide access to that Unity catalog. We go to, so on this external location, this is the location being accessed by the data lake. So click on add role assignment. So here you will find something like storage, blob, Databricks. One second, storage. Let's search with the Databricks. Storage block, what we have? Blob data contributor. There should be something related to the Databricks. Let's see. Data blob. Let's choose this data contributor. Let's see on the other account what I have provided. External ADB access. Add role assignments. Okay, let's see this role assignments. Um, where it is? One second. One second. I'm just checking the policy name. I'm not able to recollect. access control list. The data contributor itself. Okay, let's go back to the role. Okay, IAM, add role assignment. So sorry, let's go to our container first. This is our container. So on this, add role assignment. Storage blob data contributor. Yes. Storage blob data contributor. Select this and click on next. Here we need to add the members. This member is nothing but now it should be accessed by the Databricks. So we should provide Databricks related things here. If you select on add members, it will show Unity catalog access connector. Okay. So this data lake has to be accessed by the Unity catalog. So select that. Okay. Review and assign. Okay. The role assignment is done. Now let's come back to this. Now let's try to create the tables using this location. Okay. Let's see. Go to workspace. Let us create a new work notebook. Let's rename this as Unity catalog. Okay, so let's try to create the table. I'll just create a dummy table. Create table. The table name is test Unity catalog with the columns as ID and the name as a string. So I want to create it as a delta table. Delta, and here we should provide location. The name of the location is, one more thing, we need to see the details. In order to see the external locations, there is a command called show external locations. Okay, so run this. This should be a SQL cell. In order to run the SQL commands, this should be a SQL cell. You can select it from here, which type of cell do you want. Okay, let it run. So here it has selected the serverless. Later we'll switch to the other compute. The test cluster is also available. Later we can switch to that, but let's see. So these are the external locations we have available for us. So what is ours now? This is the one we have created right now. Okay, into this location I want to create the table. Okay, so copy this location. Okay, so now this becomes the external table. Let's create it. So in the interviews, they might ask you, how do you access data lake from the Databricks? So that is possible through Unity catalog and enabling the external location. So before the Unity catalog, there was something called mounting. Mounting means in order to be able to access the files or the things available on the data lake to the Databricks, we have something called mounting. But instead of mounting, now Databricks has enabled Unity catalog to access the external locations. Okay. So there are two options. One is through mounting, another is through Unity catalog. So nowadays everybody is choosing the Unity catalog. Nobody is relying on mounting. Okay, mounting is a legacy method or the older method. It is getting outdated now. Okay. So let's go into this location. Now this location is nothing but this is the storage location. Even in the real time, if you see some location like this, if you directly click on this link or something like that, you will not get anything. What you have to understand from this is the second part after at the rate and before DFS. This is the name of the container. So you should go to here and open that container. DE training data lake is our container. Sorry, a storage account. Okay, data lake. After that, how we need to interpret or understand this external DB you see, this is the container name. So go to containers, external DB, this one. Okay, this is the container, and in which path are we placing the files? So in that we are placing the files in this Databricks Unity Catalog external. Databricks Unity Catalog external. Even the naming standards will be like this in the real time. By looking at this name, I mean, if you are the new person to the project, you might not understand what is this DBUCEXT. We will not be able to understand. We might feel crazy like what this is, how, what is the meaning of this, who has named this. You might feel all of that. Even I felt that in my initial days. But for any name they are maintaining, there is some meaning to that. Okay, they'll not use any random names. There is definitely some naming standards and they'll follow that. Those naming standards are not by Databricks, they are by their organizations, or as a standard practice they will follow that, so that everybody whoever is new to the project, let's say today I'm working for this, after 2 years I might be switching the company, somebody has to come in my place and they have to take it forward, right? So for that they'll maintain the standard conventions. It is not like I'll maintain test here, no, that is not allowed. Not allowed in the sense it doesn't restrict you to create it, but your managers or your peers who are reviewing your code, they will not approve that. Okay, unless and until you provide some meaningful names. Right. So now here we have created a table in this location. See here it is created with the current timestamp. Is it already 10:40? Oh my god. Okay. If you see, there are some files created. One is the .crc, another is the .json, and we have something else also. So let's look at all of this, what it has. If you go to edit, so this is the transaction ID of the table creation. Okay, number of files is 0, deleted records. It is the transaction log, what happened with this operation. Number of deleted records is 0. We did not do anything, only metadata. Number of metadata is 1. Metadata is nothing but the column headers. Okay, so there is nothing else. So for metadata, there is also an ID created. The format is Parquet. Parquet is a default format on the background. It is not the input file or the input type we are managing. Okay, here we have some struct type, struct fields. The column name is ID and the type of it is integer. And another column name is the name and the type of it is string. So it is showing the metadata related informations. The partition columns, is there any table or any column on which we are doing a partition? No. So it will have all the details. You can go through if you are interested, but just letting you know. Okay, so now this is a JSON file. Let's see what it has. Okay, it has the user details. Who has run that? Okay, at what time it was run. So this is the timestamp. This is in epoch. Epoch means, let me show you. Epoch 2. Timestamps will be sometimes in epoch. Epoch means the 10 digit or the 12 digit number. It should be uh, converted to the human readable format. Epoch number is not in a human readable format. Let's see. I'll convert this timestamp to IST. Okay. Epoch to IST converter. Sometimes you will come across this timestamps and you will be wondering what that is. So provide the timestamp to readable date. Okay, it is May 23rd, Saturday at 5:11. This is the UTC time zone. GMT means UTC, and this is the Indian local time. Okay, this number indicates this time. Okay, now this is human readable, but if you tell somebody this is the time, they don't understand anything, because this is a system time, not a human readable time. So just to show you that this is a timestamp, nothing else. I have gone to that epoch thing. Okay, user ID, this is the my user ID and username, and what operation I have done, create table, and if there are any parameters, partition by, cluster by, no. So if it is a managed table, no. And what are the properties? Some deletion vectors. These are all some advanced concepts we don't need. Okay, some run related details. The run related details are stored in this. Okay, let's try to do some operations on this, and also let's see this. What is here? This is an empty. Nothing is there in the staged commits. What is here? This is also an empty. Okay, nothing here. Now let's try to insert some data into this. Insert into this test catalog value. Just make one entry. Let's run it. Okay, number of rows affected is 1. Let's see what happened here. Let's refresh. Go to this folder. So now the partition. What is there in the delta log? See here now at 10:48 another .crc, another .json is created. First of all, let's go back and look at this partition. Go to edit. So it has the data. It is not readable because the data is in a Parquet format. Parquet files are not human readable formats. You will not be able to open the file like a CSV file and you will not be able to read it. Okay, so this is not human readable. I'll tell you what Parquet is later. Okay, the data is stored in the Parquet files. So whatever the table is, that is what I'm telling. The delta files or the delta tables or whatever tables, in what format they will be stored on the background. They will be stored as a dot Parquet. Okay, so in this, let's open the CRC. It is the transaction log. This CRC is nothing but the transaction log. So the transaction ID, table size, the amount of data we have written, number of files is 1. No deleted records, no deleted. And what else? Provider, Parquet. This is the transaction related. Maybe somewhere it will show the insert operation has happened. Let's scroll. Created time, minimum reader, writer, write features, operation. Or let's search for insert. Okay. So what has happened with this? Insertion happened. Okay. So this is the transaction log. Generally, we don't look at that, but when we come across some issues, what happened to that, in order to trace back, you will come to here. So in the JSON file, what you will have, this is the user or the run related details. Okay, let me show you append mode. The mode is append mode. We are writing the data into the table. Okay, somewhere there would be the data as well. See here, yeah, this is the data. Okay, this is the data. ID number is 1 and this is the data. So how many ever the rows you insert into this, delete into this, that many number of Parquet files will be created. Let's say I'll do another insert. Now this time with ID number 2 and the names I'll take it from here. Okay, so also insert another row, three rows. Sorry, 2 rows, inserting 2 rows. Again, a log file will be created. Let's go to, let's refresh here. See here, another 2 files were created. This is a transaction log. It will show the data size, all of that. Okay, insertion time. This is the data ID 0, name 0, no. Okay, this is the data ID, name, ID, name. number of records too. So it is giving some statistics, and similarly the .json file. It also shows the run details. Here also, okay, the number of rows, the actual data. Okay, so and again a Parquet file will be created. Let's go to here. See here another Parquet file is created with the 1052 timestamp. Let's expand this. Okay, another Parquet file is created. See, if you see here, this is the Parquet file. Okay, so it will create the file versions. Or if you want to see the data directly in the table, you don't want to see the files. Let's see, select star from test UC, sorry. Okay, you are able to see the data as usual. How is that history possible? That history is possible through the file versions on the background. In the managed table, you are not able to see, but in the external table, now you are able to see, right, what is happening. Now, let's query this. Select star from test UC. We have already seen this version as of 0. The version starts with 0. Okay, at the 0th version, it will be referring to that file, the very first file. It will be referring to the, let's go back. Okay, in the delta log, it will refer this the first two files. So from this, it will be able to understand there is no data. So when you say version as of 1, let's see if it has any versions here. Edit version. Okay, this is not the one. Okay, so maybe on the background it will maintain those versions. Or let's see this. This version is different. So, anyways, the first file will be the 0, 1, so 1, 2, 3, and so on. Based on the version we are selecting, it will read from that particular file. So in the interviews, they'll ask you how the delta tables will be able to retrieve different versions of the data. That is possible through the Parquet files it was storing for each transaction happening. Okay, it will go into the particular file and check what was available at that. So version as of 1. As of 1, there will be one row. Okay, so that's how we'll see. So now let's describe this table. Describe extended test UC. Sorry, extended. Okay, let's scroll up. Here if you see, now the table type is external. Earlier it was managed, and this is the location of that table. Okay, so those are the important things to note here. And this catalog is this one. It comes with this catalog is by default. Let me show you. It will be auto created whenever Unity catalog is created. Okay, this will be auto created ADE ADB. The name might be different because the name of the data bricks I have spun up is ADE ADB. That's why the catalog is created with this name. If you have created with some other name, it should have created with some other name. Okay, so in that database and the default schema, there is this table. Okay, now let's say I'll drop this table. Okay, if you drop the table, before dropping, I want to tell you a few things. If we drop the table, the external table. Even though if we drop the table, the files still exist in the external location. But if you drop the managed table, the table and the files both will be dropped. Even though you are not able to see that files on the background, the files will be dropped. Okay, now let's also see the history. Describe history. Describe history of what is this table name? Test UC. Okay, so it has three versions. The first is create table, another two are write operations. So it has happened through the notebook, and these are the query IDs, cluster IDs, all of the details. Okay. So now if I drop this table, the files will still be existing. Let's do that. Go to workspace. Here you see. So people also call Unity catalog as the UC. Don't get confused or okay. Now after history, now I'm dropping the table. Drop table test UC. Before dropping, let me also show you here in the ADB database default schema. You have two tables. One is test table. This was the one I created earlier, and this is the one we have created right now 6 minutes ago. Sorry, 18 minutes ago. Okay. So now I'll drop this test UC. Drop table test UC. If the table is dropped, let's go to the catalog and refresh. Okay, let's go to ADB default. There is only one table now. Only test table is available. Let's go to the external location and refresh it. Refresh. So we still have the two versions of the files. Okay. So in the real time or in the interviews, they'll ask you what type of storage is preferred, either managed or external. Okay. So mostly the managed location will be sufficient to handle the workloads. But when we choose external, so unfortunately, let's say if we drop the table, mistakenly someone dropped the table and you want to retrieve the data back. In case of managed table, we won't be able to get it back, right? So that is why we maintain external tables, external location. So the data will be secure, or if you want the data to be stable, durable, secure, better to go for external stage. Otherwise, go for the managed location. Externals, I'm getting the word external stage, which means the external location. Okay. Right. So you will see in the real time also, you will see most of the times people using the external stage because that is the most secure way. Even though it cost us, that would be the secure option. Even though we lost the data on the tables, you can still come to the files and see what happened. Hope you are able to understand what this Unity catalog is. It takes care of everything in the Databricks. Okay. The you can be able to maintain tables, files, delta tables, time travel, everything. Okay. If you want to know if your account is enabled with the Unity catalog or not, you will see. If it is enabled with Unity catalog, you will see these options: govern, connect, and share. Otherwise, you will not be able to see these options. Okay, govern. This is for the data governance. So before coming to the data governance, let's try to create some data sets and see. Share, if you want to share it with somebody else, you can go to that. This connection is to connect various things, and govern is data governance and security. Let's check this. Govern the tags. Okay, it was showing there were some tags here. Age, if you don't want to show the age of the people, you can use this. Or if you don't want to show some medical information about a patient, you can see this. There were already created automatic policies in the Snowflake. If you remember, we have a masking policy, right? So the similar kind of these are the similar kind of policies. If you don't want to expose, you can use this. So this is a credit card related policy. Okay, credit card number containing 12 to 19 digits. This current tag is managed by Databricks and it allowed values and description cannot be changed. Okay, let's go back. These policies you cannot create. If you want to create any other policy, you can create it here. Okay, I'm not going to create the policies now. Let's see. Go to the govern data classification. Let us see if we can classify anything. So there is only one table available. Let's create another table in the Unity catalog and come here. Let's also maintain some sensitive information. Go to workspace, this one. Create the table. Create table. Customers. I'll maintain it as a delta table, but not a external table. Okay. ID, name is, age is also an integer, and phone number. Let's make it as a string. Phone number is a personal information. We should not expose that. Age is also a personal information. We should not expose. Name and ID are the generic things. Okay, and let's say his credit card number or Aadhaar number. It is a string. Let's see. Email also. Location, I don't want to maintain any location. So just the delta. Let's create it. Now this becomes the managed table. Okay, the table is created now. Let's describe that table. Describe extended customer. All these concepts are really important for the interview and also for the real time. I don't know why people are dropping. Okay, anyways, okay, this is managed table now. I did not provide the location, so it has become the managed and the storage is within this storage account. DB storage, some code is there. Within that, it is getting stored. Okay, right. Now let's try to insert some data into this. Insert into customers. Okay, let's go with this default options. Okay, so okay, let's close this. Okay, what columns we have? ID, name, age, phone number, credit card, email. ID, name, age, phone number, credit card, email. Okay, let it be. Let's create it. Sorry, insert it. Insert the data. Select star from this customers. Okay, this is the information available. Now let's go to this Unity catalog. Let's refresh it. Okay, govern data classification. So now the table scan. Why is it only one? Let's see where it is created. The other table, customers, default. Okay, there are two tables, customers. Okay, let's go to again the catalog, govern data classification. No classification data available. Uh, let's see here, manage catalogs. This is already enabled. This catalog is already enabled. So scan complete. Review detected classification tags. Okay, no class. There are no classifications available. Generally, it should detect the sensitive data. Scan complete. One table scanned in the last 90 days. One second. This is all tags system. We don't have any user defined. Let's try to create phone number tag. Allowed values. Create a govern tag. Will allow a defined tag with a set of allowed values and permissions for who can manage and apply. And second. Okay. So we will come to this later. This governance and security. I'll come to this later. It was not detecting. I'll try to see. And coming back to the workspace, you have understood what a managed table and delta table. These three are very important. In the delta also we have managed and external. Managed and external refers to where the table is locating. Okay. Delta is a different thing. Delta means it takes care of schema changes, or it takes care of the time travel. It maintains a Parquet version of the files on the background. All of that is applicable to delta tables. Okay. So now we will see, I will read that sales file. I will partition that and see how many number of partitions are there. Let's first upload the file into the catalog. I think I have already uploaded. Let me see. Volumes, test files. You already know how to create a volume. I'm not going into that. Copy this path, read this file. To spark.csv of the file, followed by header equal to true, and info schema is true. Okay, let's display this. This is a SQL cell, that's why it was showing in a different color. Okay, so run this now. See, this true is case sensitive. Okay, now let's try to see the number of partitions in this. So in order to get the number of partitions, we should not use serverless. Okay, let's see df.rdd dot get num partitions. This is to get the number of partitions on the available data frame. Let's convert this to a Python file. Okay, RDD is not allowed on serverless compute. Okay, so now let's switch it. Let's switch the compute. Serverless. Let's see more. I have created another one. Okay, let's select this test cluster. Start and attach. Okay, this is not a serverless. We are able to manage the number of resources here. Let it attach. That compute will be available in the compute tab. The clusters will be available in the compute tab. Okay, the cluster is starting. I think it might take a little time to start. It is taking time to start it. So with the serverless, you will not be able to get the number of partitions. So we should switch that to uh, the manual cluster or the all-purpose cluster. It is taking a lot of time. Okay. Let's create a new notebook meanwhile with the serverless so that we can work on the remaining things. Create notebook. Let's attach serverless. The serverless is attached. Now let's also read the same file. And that is a separate data frame. This is a separate data frame that is running on another cluster. The cluster is still in the start mode. Okay, here you are able to see this. Now I'll do this repartitioning. Df dot repartition of, let's say I want to segregate it into 10 partitions. Okay, so it has 1 lakh rows. Maybe each one gets 10,000 rows. This is one of the optimization technique. Repartition is one of the optimization techniques so that the data will be repartitioned. Sorry, this is a SQL. Let's make this Python here. So after changing the language, we should again run this. Otherwise, it will not be able to understand what DF is. Okay, this is not a SQL. 1 second. Okay, so now the data frame is distributed into 10 partitions. Now, let us say I will apply a filter. Df dot filter of what I can apply a filter on. Item type equal to snacks. Let's see. Item space type. Item space type double equal to snacks. And display this. So now the data is distributed into 10 units. This operation would be faster now. Because it has small units, maybe the snacks is fit into one of the partitions. Item type. Okay, let's accept this. There is a space, that's why it was not working as expected. Okay. So see here, it has 8 tasks, which means that why is it getting only 8? It is equal to the number of partitions. This number of tasks should be equal to the number of partitions. Let's make it dot repartition. So maybe this snacks is split across 8 partitions and it was scanning those number of partitions, it seems. Okay, anyways, my intention is the number of tasks should be equal to the number of partitions. Okay, the number of jobs should be equal to the number of actions. Let's say I'll also do df dot count. display is one action and count is another action. If you see here, there is a number 2, which means 2 jobs are created. This concept is very important. The number of jobs equal to number of actions, and number of tasks equal to number of partitions. Now it has 9. Okay, now I understand this. Filter snacks is available only in the 8 partitions. That's why it has scanned 8. In order to get the count, it should fully scan that data. So I have created 10 partitions, but why is it showing only 9? One second, let's open this. It has totally read 1 files. 1 file. Wait, I'm just seeing where is the partitions. See query profile. This is for what? This is giving a detailed execution plan. Uh, if we get the number of partitions, that would be good. Let us see if it is still in the starting mode. Even though we are specifying the 10, maybe because of the data volume, less data volume, it was not able to uh, get into 10, and maybe it was ending up in 9. That might be the scenario. That's why when we are doing a count, it is showing only the 9 tasks. This task equal to number of partitions. If you see here, this 9 partitions, this has the data reading is 1 lakh rows. Here the data read is only 8,000 rows. 8,000 rows is split across 8 partitions. It is not only snacks, the item type is not only snacks, maybe other data is also there, but in order to get the snacks data, it is split across 8 partitions. That was what is happening. Maybe the data was only split into 9 partitions. Let's try to collage the data. Collage means there are two things. In order to rearrange the data, we have two things, collage and repartition. Repartition is generally used to increase the number of partitions. Let's write repartition. These are all the optimization techniques. You should be well aware of this. Repartition. Increase the number of partitions involving data shuffle. And there is another thing called collage. This collage is different from the collage we are using to fill the null values. Okay, decrease the number of partitions without shuffling by, I'll tell you. Yes, by merging the partitions. By merging the partitions. Okay, let's take some data. Open an Excel file. These concepts are very important to understand. Okay, so we have some country data, India, and some customers in that. Let's assume India again to another country, US. The same example we discussed last time, if you remember or not, I don't know. Russia, 4. So assume that these are our customers. Okay, customers data from each country. Let's say this is the first partition. Okay, first partition, second, third, and fourth. Let's say we have some other customers here. 5, 6, 8.  6, 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 8. 9, 10, 11, 12, 13, 14, 15, and 16. Let's say the customer data across the countries. This is available in 1, 2, 3, 4 partitions. This is for partition 1, 2, 3. Sorry, this is 3, and finally this is the fourth partition. So what happens with repartition and collace? So let's say repartition. We have already 4 partitions. Okay, let's say I will also do again repartition with 4 columns. Okay, repartition into 4. Okay, now let's make it some changes. You will be able to understand clearly. Now India is here. There India is here. Now US and Russia in the first partition. Okay, let's assume this is the data, and now we don't have this fourth partition. Okay, so now in case of repartition, I want to repartition this into 4 units. 4 units, I want to repartition that. So how it will do, it will put all the country together. Let's say we are repartitioning based on the country column. It will put all India together. The data rearrangement is happening. It is sharing the data, or it is cross-accessing. This node is communicating with this and it is asking, hey, do you have the India data? Similarly, this is asking, hey, do you have the US data to the other partitions? There is a cross communication happening. So the repartition is like this. So India data is all together in the partition 1. Now in the second partition, we will have the US data. US 3 and US 15 and here US 7 and 11. Okay, this is second partition. Similarly, third also the same country goes into the same partition, Russia and another Russia. And here also, and one more. So we don't have any other country, right? India, US and Russia. Okay, I want to split this into 4 partitions, but now I got only 3 partitions. Now what it will do is, it will try to equally distribute the data. So India now has 6 rows. Okay, let's try to take 3 out of this, 3 rows out of this, or 2 rows out of this, and make it into partition number 4 in order to equally get the data. Okay, or maybe one row from here, it will be taken to here. It all happens on the background. We cannot decide. We can just say either to distribute into 4 partitions or distribute based on the country. Even though we say that sometimes it can do its own decisions, okay, in order to optimize the data. Let's say now this 9 and 10 are not here. 9 and 10 are not here. So now this is into 4 partitions. This is what is happening with the repartitioning. It is checking all the partitions and getting the same data together. It might not be the same data, but some comparison happens with the other data sets, and we will be getting it into the mixing, or we can say the rearrangement is happening in the repartition. This is generally used to increase the number of partitions. Repartition is generally used to increase the number of partitions. Okay, now in case of collace is also to arrange the number of partitions but without shuffling. Here the data shuffling is happening, which means that the data in the executor 1 has moved to executor 2 and 2 has moved to 3. Some type of data sharing happened. But in case of collace, the data rearrangement or the comparison doesn't happen. So let's say now I have 3 partitions. I'll just say that split into only the 2 partitions. Collace of 2. I'll maintain like collace of 2. what it does now. So the first two partitions will be as it is. There will be no change in the first two. And there is a data in the third partition. We cannot ignore that, right? We should split it. So now it has 5 rows. So how it can split? One partition will get 3 rows, another partition will get 2 rows. So it will randomly pick and place it into the existing folders. Let's say I'll place 3 here and another 2 in the other partition. It will just directly take the data and distribute it. Okay, it will not actually look into the values and compare. It will blindly put the data few here and few there into the existing partitions. Here data shuffle is not happening because it is not comparing. It is just taking the data and dumping into the existing partitions. But here it is comparing. Comparison in the sense, partition 1 is India. When the next row comes here, it will ask, are you belongs to India or not? If it is India, then only it will allow. Otherwise, it doesn't allow. So that is the difference between the repartition and collision. Repartition data shuffle happens in case of collision. Data shuffle doesn't happen, but generally used to reduce the number of partitions. So now let's go to our notebooks. Okay, let's try to do the collision. Repartition we have already seen. Let's do collision now. Df dot collision of. I'm not telling which column or what. I'm just making it like do it two partitions. After two partitions, I will again run this filter and the count. Now this time, let's see what happens. Let's run this. Okay, why only one of the operation happened? I'll tell you because this was already executed. So it has stored the results in the cache and it was picking from that. Oh no, it has executed again. Okay, again it is showing 8 and 9. Maybe this data frame is not getting affected. Let's do one thing. PF1 equal to, let's try this way. Okay, so now I'll apply it on the DF1. The other one is also getting executed. Let's see now what happens. Okay, now on the filter, I have only two partitions. Okay, it has scanned the two partitions, but it is giving one extra because here also, if you see, there is one extra when you are doing the count. It is like it is collecting data from the all partitions, and in another partition, it is completing that. It is completing the addition. Maybe that is what happening here. Okay, let's ask why it is giving addition. Let's go to this chat genie, not the generate the code. Why count action is showing one extra partition. One extra partition or task. Sorry, here it should generate. Count action is showing one extra task than number of partitions defined. I think it is obviously because of that addition itself, but let's try to make sure. And here we have defined 10 partitions, but it was not able to segregate into 10. It has tried its best to make it into only 8. Verify the count partition and inspect the count. This is not working, that is the problem. If we get the counts, then it is obviously clear. Test cluster. Okay, it is there. Let's try to run and see. DF is not defined by the cluster, and it was not what this DF is. Let's run it. Okay, it is running. Let's see. Why 3 Spark jobs? We did only the display, but why is it running 3 Spark jobs? Maybe it was split into 3 partitions. Okay, let's see what it is. See, all these options, we do not have it in the free trial edition, right? So this is the difference. Uh, Tag visualization. So all these operations happens on the background to read the data. We don't need to understand all of this, but just telling you. So there are 4 tasks created, which means there are 4 partitions. Let's try to see if we have 4 partitions or not. 4 partitions or 3 partitions. Let's run this. What? Even in the test cluster also, it was not able to detect the number of partitions. We are not using any shared environment. Using. Okay, let's see how we can use this. Okay, nothing here. But ideally it should show the number of partitions. So number of partitions. It was telling something. I think it is 4. Number of jobs equal to number of actions, but let us see. Okay, I can add a small explanatory step. In your notebook reduces the data to 2 partitions, but DF, see here it is telling the reason. In your notebook, police of 2 reduces the data to 2 partitions, but count can still appear as 3 tasks in the job or stage. The extra task is expected and it doesn't mean Spark created an extra data partition. Okay, it does nothing unless you assign it. If you want, I can add a small explanatory cell to the notebook showing the partition behavior clearly with 3 partition. The final reduce step. This reduce step is nothing but the 10 partitions or the 8 partitions. It has created 8 counts. In each partition, it is giving the total count. And finally, it is trying to combine that. That addition itself is called as a reduce step. Yes, that is clear. Okay, even though this count partitions is not working, but that is how it is. Let's see, it has given another method. Hmm. 4 partitions. Let's do the same thing in the other notebook. Delete this. These are the tricky things. Why? Maybe in the interviews they'll ask you why, and it shows another task for the count action, even though the data frame contains only 4 partitions. Why does it show 5? Because the reduce operation, the final step, it will count the data from all the partitions. What does it do? The count, why is it 9 tasks? Okay, again the count, it is showing 9 tasks. Let's say, okay, let's do collays on, or else on the df1. On the df1 we did collays. Here it is showing the number. Total there are 8 partitions, and the date, and with the collays df1, it is collays, it is showing 2 partitions. Okay, even though we have split into 10, it did not make it into 10. Let's again try that with the df2 equal to df dot repartition of 10. Let's run this. Okay, the repartition happened. Now let's try to see the number of partitions. Syntax, you don't worry, you will get it anywhere in the ChatGPT or Google. Let's make it as number 2. Okay, it has 10 partitions. It was able to do that, but with the filter, that filtered data or whatever we are trying to upload, that might be available only in the 8 partitions. Now let's try to apply the filter on df2. df2 and see how many partitions will be scanned. This number of partitions scanned is equal to the number of tasks created. Oh my god, why is it 18 now? I think within each partition, it should be only 10 or less than that. Let's see the query history. The same number of rows, it is from the same file. Why is it showing 18? So it is showing the number of seconds or the how much time it has spent on each operation. But where come that 18 is getting? From where it is getting? Maybe internally it was split. I think so. Let's see. Hmm. Come back to workspace. This one. Okay, let's run a genie on this. Why the tasks are 18 even though we created 10 partitions? see here the number of tasks can exceed the number of partitions due to internal Spark optimizations. Spark is doing something on the background, such as splitting the partitions for parallelism. Even though we have defined 10 partitions, in order to make it faster, it is internally splitting again. That's why it was showing us 18. So no problem with our code or our explanation. Spark is internally trying to even optimize that. Okay. Accept. So that's about the coalesce and the repartition. In coalesce, data shuffle doesn't happen. In repartition, data shuffle happens. So also there is one more thing called broadcast join. You know the joins, right? The joins in Spark, we have discussed it. So broadcast join is like if you are joining a small table with a huge table, the copy of this small table should be maintained across all the machines so that data shuffle will not happen. That helps in optimizing the query. Okay, let's see. I'll have I will have a single data frame. Let's say for each country, I will have a ID. I will create a table called country, or what I can see, or I'll just make this sales channel as a table. Create table, sales channel. Uh, Instead of the table, I'll make it a data frame because this is a data frame. Data frame has to be joined with the data frame. Data equal to list of ID, comma, online. Online is one and offline is two. Those are the only two rows I want to have. Two, comma, offline. That's all. Now df dimension. I'll make it as a dimension equal to park dot create data frame of data, comma, what is the schema? ID and mode. Let's make it ID and the mode of the selling. It is online or offline. Okay, let's display this. Okay, offline and online. Let's say now I want to join these two tables, two data frames, not the tables. One is this df2 or df. You can just refer df, that's fine. I want to join this. Df join equal to df dot join of another data frame is df dimension. I'm directly joining without any shuffle operations. Okay, on this sales channel equal to the mode, and the type of this is inner join and displaying that. Okay, so it is completed. Let's see this code. Okay, ID online offline, the ID is being displayed. Now let's look at the performance. It has scanned 3 partitions. This data size, this sales channel is very small, but I'll show you the syntax. How do you broadcast generally? Now, if this, let me use df2 dot join because it has 10 partitions. Maybe we'll see the change in the number of tasks. Okay, now see, it has created 12 tasks. Now I'll do a broadcast. Broadcast means this is a small table. This what is this table? Df dimension. This is a small data frame. It is stored in one of the partitions. So all and this data, sales data, this is available in 10 partitions, and each partition has to come to this dimension partition and ask, do you have the data? Do you have the ID1? Do you have the ID2? Everybody has to come to this and ask. Okay. So now instead of that, what we should do is I will maintain a copy in each partition so that it will not go into the other partition and ask. Instead, it itself has that. That reduces the execution time. Instead of everybody going to one person and asking, do you have this or not? That not, person is not a best example. Let's say there is a textbook. Inside that there is some information. Instead of each person going to that textbook and referring the page, it would take time. Otherwise, what we are doing is, for each person, I am distributing the textbooks. I'll create 10 textbooks and give it to each person so that it would be the faster operation, right? So that's the meaning of the broadcast. So now broadcast join equal to df2 dot join of broadcast of the dimension table, the small table. Okay, just that here it changes, nothing else changes. Okay, we need to import it. Okay, from PySpark.sql functions, import this broadcast. Indentation, where is this? Okay, here. Okay, so the broadcast one, let's see the performance. You might not observe the huge difference, but in real time, in case of huge volumes of data, there will be a difference. 1 second, 74 milliseconds. So how about the other one? It is 2 seconds, almost half, right? So this way we can reduce the query time using the broadcast join. These are all the optimization techniques. And another thing is we have something called cache. Cache means store the results in the memory, and persist. But to store the results in the memory, there are two options, cache and persist, with some differences. Cache and persist. Persist. So what it is, cache means the data is stored in the memory. Anyways, the Spark does in-memory computations, but if you are doing the same operation, then there is no change in the data on the data frame, and the join produces the same output. Instead of rerunning this again and again, I will store that in a memory, and instead of running the query again, it will just pick from that. It is like you are preparing a cake. You already have the cake ready. Instead of preparing it again, there are no ingredients required. They want the same type of cake, so you have it already. Instead of rebaking it or recooking it, you can just pick from that. If a new customer comes with a new requirement, they want to add something else like a cream or something or some colors, then they will re-prepare it. Otherwise, they will give whatever is existing or whatever is already prepared. So for those purposes, we'll be using the cache. In the cache, results will be stored in memory by default. We don't have the option to say where to store. Okay. So in case of persist, results will be stored in the memory or the disk. We can have the flexibility to define. We have the flexibility to define where to store. Okay, let us see. Okay, so let's say I want to store this broadcasted result, dfbd join. This data frame I want to store. Why we use a cache? If we are using the repeated data frames, if we are using the same data frame multiple times or repeated number of times, we can go for cache, df.cache. Okay, let's run this. Persist is not supported on serverless compute. Let's switch back to this. This is also switched to serverless. Where? Sorry, not this one. 1 second, let's refresh. Okay, maybe it has become inactive. Let us see. See, that's why I told some options are not available on the serverless single node. That is a free trial edition. Some things require the paid accounts. Now come here. Let's do cache here. Okay, the test cluster is available, but before that we need to have these two data frames. We need to have these data frames on the on that environment. So let's create this. Sorry, this is a SQL, so let's make it Python. Syntax error at or near data. What error? We just copy pasted it. What error it is? Okay, it has created. Now let's try to join that or broadcast that. I'll directly do the broadcast. We have already discussed the join. Okay, broadcast. So again, this is a SQL converted to Python. Instead of df2, let's use df. Okay, observe the difference now. Okay, two Spark jobs. Because this join, see here, two Spark jobs and two stages. Jobs equal to number of actions, but the stages equal to number of transformations. Uh, Number of shuffles. Stages equal to number of shuffles. What it is. Okay, I think it has totally created three stages because of this join operation. Okay, because of the join operation, it has created three stages, which means two shuffles are happening on the background. One shuffle leads to two stages. So, which means here there are three stages, which means two shuffles are happened on the background. Okay, now it has taken how much time? See, when you run the job on the cluster, interactive cluster, these all are being displayed. When you run it on the serverless, nothing is displayed. Okay, that is because in the serverless, everything is managed by them. We don't have the flexibility over there. So now I will try to broadcast, sorry, cache this. bd.join cache. Convert this to a Python one. Okay, now this is broadcasted. So if you want to display this, now instead of running that every time, it will just display from here. Dot display or dot count. You can do anything, any operations or any feature, any filters, joins, anything. Instead of recalculating it, it will pick from the cache. Don't worry about that. It is picking from the cache. We did cache and the default option is it will be stored in the memory. So now when you do persist, dfbd broadcast join dot persist of, let's change the option to Python again. Persist of, here we can provide only memory, only disk. Okay, memory only. Storage equal to storage type, something would be there, the syntax storage type. Persist to memory. I just want to store the results to the memory, not anywhere else. Let's run this. By default, I think it would be memory syntax at or near Python. Okay, it is by default the memory. Now let's say I want to store it into the disk. Persist to disk. What? Data frame persist with the disk option. This is not what I'm expecting. Persist data frame with disk only. Disk means it will store the results only in the disk. Storage level. That is what I'm looking for. Okay, from PySpark, import storage SQL. Here the storage level dot disk only, memory equal, memory only, or disk and memory, both of them. Let's convert it to Python. Why is it getting converted to SQL? I'll tell you when it stores to disk, when it stores to memory. So when you don't say anything in cache, by default is memory, but when in persist, if you don't say anything, by default it would be memory. When you say storage level equal to memory only, then also it would be memory. And if you specify disk only, then it would be stored only on the disk. Or let's say we have provided memory and a disk. Let's see that. I'll show both memory and the disk. Okay, it is Python. Let's write this option, memory and disk. Okay, then what it will do, first it will fill in the memory. If the memory is 100% filled, then it will spill the data to the disk. Memory is like storing it in our brain and we are able to recollect it quickly. Disk means it has written somewhere, it has to collect that. Okay, it is somewhere, some other memory. Okay, so if memory is full, then only it will spill to the disk. Even in case of cache also, if it, even though it is memory only, but if we are caching the data which is greater than the size of the partitions, then it will automatically spill to the disk. The only difference is that in the persist, we have the flexibility to manage where to store the data. But in case of cache, we don't have that option. Okay, so that's about persist and cache. All these things are important. They'll definitely ask you in the interviews. And then what other options we have? Okay, we have two things called Catalyst Optimizer and AQE, Adaptive Query Engine. We can discuss that in our next sessions. Okay, other than the optimization techniques, we are left with Databricks utils. So with these two concepts, we'll be completing the Databricks and PySpark. Post that we'll be discussing the project and then we'll wrap up our training. Okay, I know this will be a little confusing. Please try to create your accounts and start practicing. If you want, I can share these exports. And also the other one. Some things will run only in the paid version of the accounts. Please wait, I'll share the file in the chat window. Unity card. You can explore more about the Unity catalog. The files are getting uploaded. Please wait. have shared the files in the chat window. Please download and let me know if you have any questions. Otherwise, we